Today we're going to be looking at the difference between rational and irrational numbers. We are looking at the real number system. The real number system is what we count with in math and are all the real numbers that you can find on a number line. But within those numbers that you can find on a number line, you have rational numbers and you have irrational numbers. Rational numbers are the numbers that can be expressed as a fraction, a terminating decimal, and a repeating decimal. They can also be perfect squares. So let's look at some of that vocabulary and make sure that we understand what we're talking about in terms of what it means. So when I'm looking at a fraction, we're talking about a number that can be written as A over B in fraction form. When I'm looking at terminating decimals, I'm looking at a decimal that ends, it stops. So a terminating decimal is a decimal that stops. For instance, 1.5 would be a terminating decimal. A repeating decimal is also rational. A repeating decimal has a pattern. So an example of a repeating decimal would be 1.23 repeating. So it would be 2, 3, 2, 3, 2, 3, because you can write a repeating decimal as a fraction. And then our perfect squares are numbers that multiply by itself. So if I have the square root of 4, this is a perfect square because it simplifies to the whole number 2. 2 times 2 is 4. So I also have the square root of 9 because it simplifies to 3. The square root of 16 simplifies to 4. The square root of 25 simplifies to 5. The square root of 36 simplifies to 6. The square root of 49 simplifies to 7, and so on. You need to know your perfect squares between 1 and 12. So you need to learn your perfect squares between 1 and 12. And you simply would go 1 times 1, 2 times 2, 3 times 3, 4 times 4, all the way up until 12, until you know those answers. You need to have those memorized. Now, within rational numbers, we have numbers called integers. These are our negative and our positive whole numbers that is not including 0. So we're talking about those numbers that you would normally place on a number line, our positive 1, 2, 3, 4, 5, and our negative 1, 2, 3, and their opposites. When we're talking about whole numbers, we're talking about our positive numbers, our positive whole numbers, including 0. So when I'm looking at a number line, I'm starting at 0 and I'm counting forward 1, 2, 3, 4, and so on. My counting numbers, or my natural numbers, are the numbers that we learn to count with when we are young. So we start counting at 1. So our natural numbers, our counting numbers, start at 1, 2, 3, 4, and so on. All of those numbers are counting numbers, the number 0, which includes whole numbers, and integers, which include positive and negative whole numbers, as well as our repeating decimals, fractions, terminating decimals, and perfect squares are all considered rational numbers. Now we move down to talking about our irrational numbers. These are numbers that cannot be written as a ratio or a fraction. They are not perfect squares. They are non-terminating, which means that they go on and on forever, so they have the ... after it. And they are not repeating, so there is no pattern to it. Some examples of irrational numbers would be pi, 5.1236734 ... This is not repeating, and it has the ... which tells you it goes on forever. The square root of 2 is a non-perfect square, so it is also irrational. Then we have the numbers that are not real numbers. We're not going to worry too much about those. They are called imaginary numbers. We are not learning about imaginary numbers, but when you have a negative under the radical or a 0 in the denominator, that is not a real number. We are only focusing on rational numbers and irrational numbers. So real quick before we end this video, let's go through a couple examples. 3 divided by 12 would be considered rational because it is a fraction. If we look at the example, 8.33865 ... this would be irrational because it is non-repeating and non-terminating. If we look at another example, 12.52, this one would be rational because it is a terminating decimal. The square root of 19 would be considered irrational because it is not a perfect square. It's going to be very helpful for you to learn those perfect squares to help you identify rational numbers. So again, rational numbers are those numbers that are natural numbers, whole numbers, integers, repeating decimals, or terminating decimals, fractions, and your perfect squares. If it does not fit into those categories, then it is irrational because it is not a perfect square, it is not a terminating decimal, and it is not a repeating decimal.